I was assigned section 1.2, problem number 17. The problem is to find the position function x of t of a moving particle with the given acceleration a sub t with an initial position x of 0 equals 0 and initial velocity v sub 0 equals 0. So the problem for the acceleration is a sub t equals 1 over the quantity of t plus 1 cubed, where v sub 0 equals 0 and x sub 0 equals 0. So in order to get to the position function, we're going to have to integrate this problem twice. So to integrate 1 over t plus 1 cubed, we're going to want to get rid of the fraction and move the denominator up and make the cube a negative. So now we have the integral of the quantity t plus 1 to the negative third d sub t. So in order to solve this problem, it's a simple substitution. So we're going to let u be equal to t plus 1 and du equal to dt. So now we have v sub t equals the integral of u to the negative third dt. So in order to do this integration, we just use the rule. So we get u to the negative third plus 1 over negative 3 plus 1, which gives u to the negative second divided by a negative 2, which can be simplified out to negative 1/2 of the quantity t plus 1 to the negative second plus our constant c. So now we're going to substitute v sub 0 equal to 0 into that equation. So we get v sub 0 equals negative 1/2 times 0 plus 1 to the negative second power plus our constant c, so we can solve for that constant. So that gives us 0 equals negative 1/2 times 1 to the negative second plus c. 1 to the negative second is just 1. So now we add 1/2 to both sides. So our c equals 1/2. So now our final equation for v sub 0 equals negative 1/2 to the quantity t plus 1 to the negative second plus 1/2. So now we have our velocity function. So we'll integrate that once more and get our position function. So when we integrate our velocity function, we can break it up into two parts and get the integral of negative 1/2 by the quantity of t plus 1 to the negative second plus the integral of 1/2 dt. And we're going to pull that first negative 1/2 out front and then do another substitution where we let u be equal to t plus 1 and du equals dt. So that simplifies down to negative 1/2 times the integral of u to the negative second dt plus the integral of 1/2 dt. And we know the integral of 1/2 dt is just 1/2 of t. So then now we're going to integrate that u to the negative second, which gives us negative 1/2 times the quantity u to the negative 2 plus 1 divided by negative 2 plus 1 plus 1/2 t, which simplifies out to negative 1/2 t times u to the negative first divided by a negative 1 plus 1/2 t, and then simplify it even further to 1/2 times the quantity of t plus 1 to the negative first. You can see our negatives canceled out in that first half, plus 1/2 t and plus our constant c. So now in order to get our final position function, we need to solve for c, which we do right over here on the right. So we get x of 0 is equal to 1/2. We substitute 0 in for t times the quantity of 0 plus 1 to the negative first plus 1/2 times 0 plus c, which gives us 0 equals 1/2 times 1 to the negative first plus c. 1 to the negative first is just 1, so we subtract 1/2 from both sides and we get c is equal to negative 1/2. So this gives us our final position function at x of t is equal to 1/2 times the quantity t plus 1 to the negative first plus 1/2 t minus 1/2. And then we can even simplify this further and pull out the 1/2 as a common factor. So we get as our final equation x of t is equal to 1/2 times the quantity of t plus 1 to the negative first plus t minus 1.